And a very good morning, everyone, and a warm welcome to the Design for Manufacture Techniques to Reduce Overall Production's Costs from my colleague, James Donnelly. Will be taking us through that this morning. Today being the 22nd of January. My name is Kieran Swale, and I'm part of the business support team, and we're ably assisted today by my colleagues, Aisling, Sarah, and Brian. This is the fourth of 8 winter webinars, and last season we had our summer webinar series. So these webinars are proving to be very successful. We're getting great feedback from industry, and you're in for a treat this morning with my friend and colleague James, talking about design for manufacture. James is going to be taking you through a model and then giving you a few practical examples, one in particular of how he took this model and applied it to a business. So you can certainly take some notes with this if you wish. The PowerPoint will be distributed this afternoon, as will an evaluation, and this presentation will be up on our YouTube channel on the SRC website. If you go into business support under current news, and you'll get this presentation. Now, as I say, this is 4 of 8. We do have another 4 coming up. Next Friday, my colleague Darren McSherry will be talking about marketing versus commercial marketing, and then we have 3 others in February, leading into the first week in March. Anyway, in terms of today, if you have any questions, would you please submit them in the chat box, and then Ashley and Sarah will bring them forward. So, James, if you're ready, can I hand over to you?
Well, thank you, Kieran. I just want to say this here webinar is designed for manufacture, and we look at the techniques to reduce overall production costs. Right. Just to give you a wee bit of an introduction, my name is James Donnelly. I work at in Southern Regional College, and I'm an innovation technology specialist in engineering. I've been working in engineering for over the past 20 years, and I have a good mixture of both hands-on experience and design experience. I've been working in Southern Regional College for currently 3 years, and I've worked in various industries from general engineering to agricultural engineering, and along the way I've developed many products and come up with many solutions, and I can take you through some of these product design solutions in a minute. Part of your design for manufacture, I think it's important to identify the design process. Here I've got like a funnel diagram. Kind of shows at the start of a project, designing of a product to the finish of the design process. You can see at the start, there's a majority of the work's put in early. It means you come out with a nice defined result. This webinar isn't a design webinar, it's designed for manufacture. So it's in the early stages of the design, which I want to capitalize on. Maybe down the line, we might do a webinar on the design process. So DFM, design for manufacture. The definition of it is design for manufacture is the process of designing parts or products for ease of manufacture. The goal is to design and improve a product at a low cost. This can be achieved by simplifying, optimizing, and refining the product design. What DFM is concerned with is reducing the number of parts in a product, reducing the production cost, and minimizing complexity in the manufacturing operations. So, to cut to the chase, DFM is carried out to challenge the design. You know, you're to look at the design in all areas to optimize the design. Many believe at this stage you're to tear apart the design, question the design, and see, is this the best way to do this? DFM occurs early in the design process because the later you leave it, the more expensive it is to go back and improve it. For example, in the car industry, once they recall a car, you know, after 10,000 are already been sold, it's a very expensive and long-winded process. So it's identifying, early in the process, but that includes taking on board your stakeholders. And what I mean by stakeholders, I mean get your engineers involved, get your designers involved, get your subcontractors involved, and get your suppliers involved. Now, it's good to embed good communication and relationship with each people or each area, because there's no point a designer designing something that can't be manufactured. And again, there's no point an engineer selecting the material that can't be bought. And again, if you're subcontracting it out, parts to be fabricated, or you're making it in-house, have a conversation with the factory to see, is this achievable? And what you hope to achieve after this, process is actually a better design, that you're not having to develop a design and change it, which is very expensive. Do the changes early, get a good understanding of what you hope to achieve. So in this webinar for Design for Manufacture, I have identified 5 processes which I believe needs to be considered when taking on board Design for Manufacture. Number 1, the manufacturing process. So understanding the process in which you're using. I have given an example of a local company I've worked with, and the company is called AH Tractors, and I help them to design and develop a compressor for spread and slurry, as you can see there on the right hand side. So to give an example, what AH Tractors wanted, they wanted to buy in kits and assemble it on site, and whatever fabrication to be done in their factory as such, or workshop. So we understood the process very early. Number 2 is the design. To achieve this process, we had to invest in the design. So that was, right, we're going to send out parts, we need to have good drawings and good design. So there was a design process put on board there. Number 3, the materials. We had to take on board the materials used because they had to be lightweight, easy fabricated together, and to do the job. Number 4 is the environment, and it's working in an agricultural environment. And number 5 is testing. At this point, it's important to understand that these are not steps or stages. They're to be done simultaneous at the same time. So there's no point designing something and then not understanding the manufacturing process or how you're going to put this together. And there's no point designing something if you haven't took on board the environment in which it's going to be operating. So I'm going to take you through these processes right away. So the first process is manufacturing process. DFM I have here is the understanding of the quantities required, the materials being used, the tolerances required, and whether or not there are secondary processes required. So I put a heading here, identify the manufacturing process. Well, I touched on it the last time. The manufacturing process is basically buying in kits, working with your subcontractors, and fabricating or welding the parts together and assembly. It's not much more to it than that. We want to keep a very simple process. We want to cut down the amount of operations in-house. This was more to do with what was achievable. This company, AH Tractors, was only starting out. They didn't want to invest a lot of resources into capital expenditure, into equipment. That would be very expensive and be basically doing very little work for the first wee while. So this was a good option to take, and I think it was the best option. But it meant that AH Tractors needed to have a good relationship with the suppliers and subcontractors and develop a set of drawings. This brings us into process number 2, as they call it, the design. Good design would be essential for the product and must suit the manufacturing process selected. So this is how each process intertwines with each other and how you can't do them apart. You have to work on them together. So I'll give a number there of examples of what our requirements were. I'm not going to read them all out, but I'm just going to say that the supply of kit to subcontractors was important in the design, using laser cutters and plasma cutters to cut out the parts, standardizing nuts and bolts and pulleys and bearings. So again, you can see the amount of subcontractors and suppliers you're dealing with. I touched on here dealing with the galvanizers as a subcontractor as well, although it's sometimes forgot about in the process, but there's an important thing I want to mention. We were able to actually speak to the galvanizers. We were able to incorporate some of his vent holes into the design, so it meant that the galvanizing material could flow in to the box section and flow out of the box section at the right level. So information like that was embedded into the actual design, which meant the subcontractor could actually take on board the information in the drawings and then deal with it. So I have at the very bottom again here, discuss the design with any and all subcontract manufacturers.
James, may I come in for a second there? This is really interesting, yeah. Very, very interesting. About 3 slides ago, you had the 5 processes, the process of design for manufacturing, and you said there were 5 steps, and you said these can happen in parallel or simultaneously, right? So I've listened very carefully to the step number 2, and there seemed to be quite a lot in it alone. I'm thinking here I like your model, by the way, that funnel, and you had all your very heavily weighted in the first, what appeared to be the first area of that funnel. Is there not, with design for manufacturing, a lot, like at the very, very early stages, and so do you not really to do a lot of planning and really like set everything out before you get into it? And I suppose that's what it's all about. But it seems to me that if these processes are to run not in a linear and not in a logical flow, but they run parallel, you need to really sit down and do a lot of what I would have called scoping out nearly.
Yeah. The thing is, it's cheaper to do these things at the start. I think the point I'm trying to make is too many times in design, I'm guilty of it as well, but a lot of times in design, we work to delivery dates, and it's the client that puts the pressure on to actually get the job out the door. But by understanding, spend a bit of time, coming from a designer point of view, I'm very much weighted into the design, but I can understand. I've made mistakes in the past where I've pushed the job out, and I had to go back and fix it, or I had to go back and relook at it again. Not to say fix it. Fix is probably the wrong term, but look at the way for manufacture. I didn't take on board the processes or the savings that could be made in manufacture, because traditionally you design it. You engineer, you come up with engineering, you fabricate, you do the manufacture, you do the sales. Each area is defined and they aren't related enough. So he designed it that way. That's the way we'll do it. Talk to HR, try to come up with the best solution. There's no point sitting and having the factory building something you can't, design better. You have to work with HR. Yeah. And I think that's missing in a lot of cases, even today. Look, it's easy said. It's easier said than done. This is not an easy process. I think, it's easy for me saying, "Oh, I do this and do that." There's other factors like customer or trying to get the job out the door. But I'm just really trying to identify that, if you do spend even a marginal more time, it will pay dividends in the long run.
Yeah. Okay. Yep. Get that.
Well, on this slide here, I've put in like a 3D model. I've done this in SolidWorks, and although this was used for us to actually look at the actual machine, see visually what it looks like, see as well how the parts interact with each other, see if there was any clashes. And whenever you have something done in 3D model like this, you can quickly come up with different ways of doing something, and you can see, can you better them? And it's important there that you can look at something and design parts that are standardized and are fit for purpose. With the technology we have today, for example, 3D drawing packages, you can break it down. You can send drawings to subcontractors to put together. Relatively easy, but it does take time, and that's the problem. What you do early in the process, it pays dividends at the end, but it's a slower process. People just want to see, I want material cut, I want the process started, I want men making this, or I want somebody making this. Listen, if you take your time, think it out through the truly best way, it will pay off. I find anyway. If I take it to the next step here, I've wanted to identify where DFM comes into its own. Figure 1 is showing very simple brackets. I call them lollipops, but they're brackets there. And what I'm trying to show you here is that using standardized thicknesses of brackets, standard design that can be repeated throughout the design, and for other projects, standard nuts and bolts can be used to fit, to attach, the parts together. Figure 2, because we're designing everything using 3D solving works and modeling packages, I was able to profile in and cut holes for locating like your box section and your bracket as such. So it cuts down the amount of jigs required for setup. Figure 3 shows, I call the banjo box. This is basically to cover the pulleys. And if you probably can't see it too well there, but there's wee notches notched out of the actual sheet steel. And that's just a very simple idea to actually show where the bracket well belong to. Again, it's a visual indicator of where to weld. It cuts out the time to set up jigs and gives you an idea straight away if you're welding the right place. Now, although this is a very simple part, it shows if you have many of these parts, the savings that you can make. This is air filter and it sits on top of the compressor. I was able, just for example, to use the compressor's own mounting holes to fit a bracket to hold the air filter in place. Additionally, you can over design the most simplest thing, but you can design a simple thing as well. So this bracket I was able to design using sheet metal, function in SolidWorks, where I was able to make one part. If you look at number 5 there, that's a flat pattern, and number 6 using 2 folds. That was able to make a part that actually would hold the air filter, above the compressor, which means it's easier mounted to the compressor. That
James,
part.
James, come in for a second there. Two things. We're getting a wee bit of a lag here, just a wee tiny bit of a lag. Just making sure, just to let you know, we're getting an ever so slight lag here just when you're speaking there. Just as long as you're aware of that. And just on question 6, on figure 6 there. So to the non-trained eye on figure 6, before you would have done this, that would have been 3 or 4 separate parts. Is that right?
It would have been, yeah.
Mm-hmm. Yeah. And for me, who's not an engineer, I can see how this is really starting to take shape. Yeah, that's a very effective illustration.
Well, my point is here, the way the AH was looking to do this before was mounted to the side of the machine, which meant more steelwork, a more complex bracketry.
Yeah.
This part probably costs £5, say, to manufacture, where previously you were talking maybe around £12 to £15. So although it's a small saving, but if you've got 10 or 20 parts, the savings soon add up. Which brings me to the next slide here. Figure 7 and 8 and 9. Look, we designed the machine and we didn't spend enough time developing the undercarriage of the machine mechanism to hold the pulleys. So if you look at figure 8, you see a drive shaft, running from the pulleys to attach to the PTO shaft of the tractor. there's roughly about 20 parts in that development, where we developed the machine, and after developing the machine, we says, look, we do need to look at this again. So we look back on it again, and you see figure 9 there is what we achieved. So there's a substantial savings in carrying out good design. Unfortunately, if we spent the time earlier in the process that we're talking about, we probably could have caught on to it, but we didn't. But look, sometimes you do have to compromise in the design, and that's really it. So you can see there the value of design for manufacturing. If done right, you can have a good savings. So the next process or step that I've considered here is the importance of material. Now, in this case, because it's a very agricultural equipment, the mechanical properties is probably more relevant in this case. So how strong does it need to be? Well, it's working outside, it's going to be attached to the front or back of a tractor, so it's going to take a knock or two. So in fairness, that's important. Originally, we designed this using like a heavier wall box section, but after carrying out an analysis on SolidWorks, we realized we were going too thick. So we were able to reduce the thickness of box section in half. This had an impact not only on less time to weld it meant it easier to maneuver around the workshop, fabricate, and actually it was easier for the actual farmer or contractor to actually operate it. And as well as that, there was less galvanizing required. So therefore, there's a saving there as well. If we were, example, putting together like a toaster or a kettle or a teacup or any other thing, there's other factors here that I've noted here would apply to them, like thermal properties, the electrical properties. So I put in factors to consider, but these factors, you'll have to change them or add to them depending on what you're actually doing. But this process can be applied to any product or any part, but it's worth taking time to consider it. And don't forget that it's all about selecting the right material, but it also needs to be easy sourced, it needs to be available, and it's cost. So you need to keep your costs on board and managed properly. This brings me to the next one, the environment. Now, I did touch on it on the previous slide. It needs to be designed to withstand the environment they will be operating in. As you see here in the photograph on the right-hand side, this is the machine mounted to the front of the tractor. It needs to be robust. It's working in a farm environment. There's going to be a lot of vibration through the whole machine. It's going to be scary operating in and around it, so it needs to have a certain amount of resistance. It's mounted in front and back. To cut it short, it's going to be in a working environment. It's going to be kept outside. It's going to get a knock, but it's not going to be, treated poorly, but it's not going to be treated with gloves on either. So it's important to understand that and what the client really expects out of it at the end of the day. He will look after it, but he will look after it the same way he looks after his other machinery. So you need to understand, put the right materials in, put the right design in, make it easy, make it strong. This brings us to the fifth process of testing. All products must comply with safety and quality standards. Some of these industry standards can be third party. As a manufacturer, these are mandatory as your CE mark and your BS standard. You do have other standards such as ISO, third party testing. But I think it's important to understand if you're manufacturing anything, put some type of testing mechanism in the process. You don't want to send something out to have it returned. Firstly, it puts you in a bad reputation. It's going to be costly because you're going to have to pay for the collection, and you're going to have to bring it back into the workshop to test or see what's wrong. So take the time, embed it into your processes. This will ultimately help improve your product, make sure that you reach your quality. So I've got a wee video here that I took from Alvin, who's managing director of AS Trackers. Yeah, Alvin, we've finished the project now, and it's been a few months. How do you think we got on?
Well, I think we got on very well. We now have around 20 machines there manufactured, so we have, and I definitely think spending the time to start the design with you really helped the manufacturing process with us, so it did, and speeded the whole thing up for us. And I just want to say thank you to you and SRC College for helping us out in that end.
Thank you. Well, as AH Tractors, Alan was saying, we were able to help him design the product. We were able to do this through Invest NI's innovation vouchers. So thanks for them for their help. And Alvin is also very thankful for the help and support. So the summary here. So just to mention, the goal is to design a product that is easy and economically manufactured. I don't really want to go through every one of these points, but I think it's important just to go through a few of them. So the summary is reduce the total amount of parts needed in a machine, develop modular designs, use standard components if possible, understand you need a design for ease of fabrication, avoid using fasteners, that's your nuts and bolts if you can. At the end of the day, you need to be concentrating on reducing the amount of work involved in production. That will lead to massive saving. And I think that's really it.
Yeah, James. We have a question or two in there. First of all, that was it's my second time or third time seeing that. That was really enjoyable, and thank you. And before you go to questions, would you mind going back to slide 3, if that's or slide 3, process 3, about stage 3, about the different factors, because I think this is fascinating, this process, to someone who's not. Could go forward one. It was where stage 3 about the material. We had all the different. You were talking about the different factors when you listed them. They were in bullet point format. That's it there, James. Factors to consider. So, for me, who's not an engineer, and you're with me at the start, and it came across from Alwyn there very obviously, where he said he was able to quickly get up to 20 pieces of equipment through your help. So down this list, you're very quickly able to, I say, James, I want it black. I want that, instead of being that grey industrial colour, I want to change the colour. I want it to be red, for example. The thermal properties, can we adjust them? Or the optical properties, the mechanical. So as a expert and as a designer, you're going through these at this. And again, my point is here, you're like interchanging all these at the very early stages, which is, for me, is as a non-designer, is really interesting.
Sorry.
Yeah, and my point is about the factors to consider on the materials in the design process, that these 6 that you've listed here to consider. Obviously, and really just how I found that really very interesting, that with the client you're able to interchange any of these factors and go into them and spend a bit of time saying, actually, you know what, think again about the thermal properties, think again about the color or the electrical properties. And my point being is, this whole design process, and particularly at the materials, because you spend more time now, when you went through this, it really hit home to me that actually, before you put the wallpaper on, think again. Is this actually going to be the right one? So I can't. Mine isn't a question here. It's more an observation to someone who's not a designer or an engineer, that this is really important.
No, I think you're right to say that, but I think ultimately, at the start of the process, what I might think what the client needs or wants, maybe not. he might have a different opinion, or he might not have an understanding of these mechanical properties. He might just think, you can just do this.
Yeah.
A lot of times, like, I'm more a mechanical engineer. If I'm working with a designer, they probably don't see the pitfalls and the process of fabricating something together. They may think that, that can be done. It probably can be done, but it can be done, maybe costs a lot more money. For example, having nice curvatures or nice plastic parts.
Yeah.
Of course, you could probably manufacture them, but the mold might cost 10,000, 50,000, and that might be outside the cost of actually producing the part. So although it may be a really nice design, there might be a conflict and compromises might have to be achieved. And it's trying to balance that, and I think, understanding this early and talking about it early, it means that these compromises, these critical decisions can be made early.
Yeah.
Like a lot of times, as I was saying there earlier, that if you make changes earlier on, it doesn't really affect changes in the design process. There's always going to be changes in the design process. What you want to do is minimize the amount of designs to be changed at the end. Look, changing the color might not necessarily be a big problem with the likes of this agricultural machine, but changing the color could have a big effect on a plastic part, because it may cause some different color parts may cause shrinkage and in different colors.
Yeah.
It's not just as easy as that. And colors might, if you're using like polymers, it may be more expensive to buy that certain material as opposed to another one. So it's important to talk about this so everyone understands the implications of these factors to consider. But the factors to consider are not just in the materials, but it's in each one of them. And what I'm trying to say is, I want to break down the barriers between, I'm just an engineer, I don't need to look at materials that much. I can have different thicknesses of steel, but fabricating you kind of want, if you can keep your thicknesses to like a standard, like between 10, we only use 2 different thicknesses of steel, 10 mil and 2 mil, 3 mil. There's enough scope there in the design that we can end up over-engineering some of the brackets, but it's cheaper to manufacture in the long run, and therefore it's easier. So discussions like that need to be spoke about. Can you get away with doing something? Is this going to be easier? And as Alan was saying, he was able to bring his cost down to manufacture significantly by just spending that time at the start.
Yeah. Well, if I may do, James, we'll have, I can see a question in the Q&A here. You're okay to take it. James, can you give us examples of some other companies that you have implemented DFM with? Is there any other companies that you could give us examples of? One of the questions.
There is other companies I could give examples of, and to be honest, we work a lot with a lot of SMEs in the business support department, and I think I would try to bring this approach into all my designs and all the companies I've worked with. It's just, it's bringing on board, that philosophy, and even bringing on board the client, telling them, spend the time at the start, and bring us on board. Yeah, I've designed a number of different products for people using this, and it has been a big impact. I wish I had photographs of different people's machinery I've worked on, but yeah, it's easy done.
Yeah, well, it's been a real enlightenment to me, and I've recently done a wee bit around innovation modeling, and that's an ongoing journey for me. So this process that you've identified this morning, with the emphasis on savings and DFM, I mean, prior to today, I just thought, well, that must be part of that's just a stage of design process, but it's like an inner stage, there's a stage within, and it's so important. And what you've been able to demonstrate through the good example and the process this morning is how, by taking time at the stages, you can save in the long run. and it's make the amendments early and consult with all the team, the multidisciplinary team, as early as possible. And you know what, James, that model that you've put forward could be applied to all businesses. I'm in the tourism hospitality sector, but I'm working with business and the digital creative sector as well, and that model that you've just identified could easily be applied to others. James, I'm now going to, I don't see any other questions, so I think we're going to be handing over to Aisling soon. So if you want to maybe move on to Aisling, I think you're going to come in and talk about our support that we can offer, Aisling.
Yes, good morning, everybody. Thank you, Kieran and James, for that really good presentation. It was very insightful, and I hope you've all learned a lot from it. I'm just coming on really quickly just to talk to you about some of the funded support that we have available here at the college. First up with Skills Intervention. This is a new programme. It's for anyone impacted by COVID-19. So anyone who's maybe been furloughed, made redundant, or financially impacted in any way at all. We have a range of fully funded accredited courses that you can do for free. So it's a really popular programme at the minute with some really, really good courses. We also have Skills Focus, which is a programme for any businesses under 250 employees or social enterprises to avail of fully funded non-mandatory training, and that's funded by the Department for the Economy. We also have Innovate Us, which would be a really popular funding stream that James would work on, and it's fully funded mentoring for small businesses for up to 60 hours mentoring for an innovation activity, so like a new product, process or service within your business. We also have innovation vouchers, which are funded by Invest NI, and the aim of those are to help kind of small enterprises tap into the knowledge that we have in the college. They're also really popular too. We also have some bigger programs like Fusion and KTPs and higher level apprenticeships, which offer really good opportunities. So if anyone has any training needs or would just like to have a discussion with us about maybe something you're thinking about doing, please get in contact with us. We're always really eager to help. The email address to get us on is betterbusiness@src.ac.uk. And just lastly, we do have other upcoming webinars, and we really appreciate feedback that we get on them all. So we're going to be sending an evaluation out after this, and would really appreciate any feedback. There'll be a wee suggestion box where you can pop in any suggestions for future topics that you might like us to cover. And also just keep an eye on our social media channels just for any updates that we have. So thank you so much, everybody, and have a good day. Bye.